This is the new Everton Stadium. It's the new home for Everton Football Club, and this will be a new, just under 53,000 capacity football stadium, due to complete at the end of 2024. The project itself is great for the city of Liverpool. I always tell everybody that's coming to work on the project, you don't have to be an Everton fan to work here. It's creating opportunities way beyond the boundaries of this particular project. I'm Aaron Scallion. I work for Select Plant Hire and I look after the UAV department. So in the first stage of the project, we used the L1 to monitor the sand infill of the dock. Now we're using the L2, we've been able to see the key benefits coming through.
We've worked with Aaron and Select Plant Hire for the Everton Stadium project in order to help them use LiDAR as well as photogrammetry. We also do site visits to make sure that they're getting along with the hardware okay and getting the deliverable results from their data set.
We're using the drone technology quite extensively on this particular project. So as well as doing normal progress videos and update, we actually use it in our immersive suite, which is a digital area where we coordinate construction work, logistics, plant movement, craneage. We can look at our digital 4D model. We can look at our construction program in its traditional format. And then we bring the drone technology here, see where we are in terms of reality. So it gives us a complete spectrum in terms of theory, model, reality. So it's proved to be extremely effective.
So Aaron and the team at Select Plant Hire have used various data collection methods on the Everton Stadium project. They include nadir with the camera angle pointing straight down, oblique with the camera pointing at an oblique angle towards the facades of the structure, as well as a number of manual missions in order to capture data around features of interest.
The L2 has increased efficiency, gathering more accurate information and been able to process it faster through DJI Terra. We're able to get real-time, fast and accurate data on a daily basis. By using the L2, we're able to generate data for earthwork movements, including volumetric data. This is invaluable on the size of the sites that we have.
There are some clear improvements in the data quality from the L1 to L2. The improvements of the sensor mean that you can fly faster for greater efficiency and collect more accurate data even when flying higher. It has better vegetation penetration because it now has 5 returns instead of 3, and it also has an improved RGB camera, which means that you can have greater efficiency when collecting photogrammetry and LiDAR data. The team on site captured 5 flights, which lasted for a total of 35 minutes. They then took the data to DJI Terra and processed it into a standardized output so it could be imported into other software for further manipulation and processing. Some of the new features in DJI Terra include the capability to classify the ground data as well as produce a DEM from your LiDAR data.
Using DJI Terra, we were able to process large amounts of data on a very fast turnaround.
So when we processed the data in DJI Terra and in Terra Solid, what we found is that the data was very clean, and when we compared it to our checkpoints, it was also very accurate to the coordinate reference system which we collected it in. So Eddie Guy's been working with Langer Oak for just over 4 years. During that time, we've assisted with regulatory training, workflow support, as well as hardware supply.
HeliGuy's been very supportive in directing us into the latest technologies and helping us understand the benefits of the various drones on offer from DJI. So we're always looking at how we can improve our processes and our management tools. I'm keen to see how we can use the technology on a more internal basis. So we're now in the critical path of our program, which is running through the internal works. So internal partitions, walls, rooms, mechanical, electrical services. And traditionally that's harder to demonstrate digitally and in a model. So if we can have something equivalently as good internally as we have externally, that'll be the next big step forward. So I'm open to ideas.